Welcome back to Tailored Materials. This time we're going to do some anodizing of aluminium and use it to measure some electrochemical impedance. So what we're going to do here is we're going to take a piece of aluminium foil and a counter electrode also of aluminium foil, apply a voltage across it, put it into some sulfuric acid, about 10% of concentrated sulfuric acid, so about 1 molar. Leave it for many tens of minutes, typically an hour, but I'm not going to leave it as long as that. I'm going to leave it for a while, see what happens. What we see here is that the voltage that we need to put on to get a reasonable amount of current goes up and up and up. And at the moment I'm applying 14 volts and getting half an amp of current through these two plates, which is about right, although it's probably a little bit high. I'm going to take these now and dry them and then compare them to the native oxide layer on the normal aluminium. So we're going to go over to the other equipment for this, put it into the impedance and measure the resistance or measure the current that flows if we apply a small AC signal to it. So here we've moved over to the potentiostat and we're applying an AC signal of varying frequency, just like in the quartz crystal microbalance, only this time it's doing electrochemistry between two electrodes that are identical. These are two aluminium electrodes that are both identical, and we're going to compare in a short while the untreated, the typical aluminium foil as it comes from the maker, and the one that we've anodized, or the one that I anodized in the previous step, which we would expect to have a thicker aluminium oxide layer, but a porous layer on the top of that. Let's move over to the graphs to see what that's done. As we can see from the graph, what we've got here is a higher resistance at low frequency for the anodized sample, but the resistance goes down to slightly lower at higher frequency, which implies that we've got slightly higher surface area. So it's not a surface area problem. It's more that the thickness of our oxide layer is bigger. And we can model this as a capacitor and some resistors, or as some capacitors and resistors, and use that to define our surface, which we can use to compare different aluminium oxide coatings, although it's somewhat more difficult to get full information out. We can always get comparative information out.